Okay, so this is still day one, Leetcode 75. We're solving 1071, greatest common divisor of strings. So we have two strings, S and T, or this is the definition of the greatest common divisor, which essentially is that for two strings, S and T, we can say that T divides S if and only if S is equal to T plus T plus T, which actually just means that T is just concatenated with itself one or more times, and that is the result of S. So we're given two strings, string 1 and string 2. We have to return the largest string x such that x divides both string 1 and string 2. So there's three examples here. First one is just essentially that if we have like string 2, which is our GCD in this case, which is ABC, and you can plug that into string 1 multiple times, twice exactly, and then for string 2 it would be once. And then you can say the same goes for string, or for example 2, which the GCD in this case is just AB, since it fits into, it's the least like length, like the minimum length that can fit into both string 1 and string 2, and make multiple combinations out of it. So for this case, it's like string 1, it makes two, it makes 3 times, while string 2 makes 2 times. So the reason why it can't be AB, like it can't just be string 2, is because if we try to plug it into string 1, we have AB, which is once, but then we don't have the other half of AB, the two ABs. So that means that this is not a valid GCD. And for like example 3, Leetcode, is just that like none of the characters actually match. So there's no common divisor or greatest common divisor between the two strings here. So the constraints is that we have English uppercase characters, and that the length must be between 1 and 1,000 for both string 1 and string 2. So to start off, let's create a little algorithm that will go essentially just compute the largest string that we can find in both string 1 and string 2, that like the largest string that can divide both of them. So the way we can do about that is we can go through both of the strings, string 1 and string 2. We can find the minimum length one, right? Because we know that if x is greater than both string 1 or greater than either string 1 or string 2, then that can't be like a value that divides both of them. It would be going over, so it wouldn't be compatible with the constraints or the requirements that were provided. So we will take the minimum string. So let's take example 1 in this case. So we get ABC, right? And we can start off, it doesn't matter whether we start iterating through like the beginning or start from like reversing or decrementing our count. So we'll take like the maximum. So we'll take ABC, and we'll try, it will just be faster in this way. We can try to plug it into string 1. So we can say, okay, we have ABC. Are we able to create sort of like a base string out of this? So like our base string will be ABC. Can it divide? So can it be multiplied in or divided evenly across string 1 and string 2? So the length of ABC, right, is 3. So that's our base. So are we able to take the mod and get an even number out of it, right? And if we're not able to, in both of them, we need to be able to get a even number in both of them. So for ABC in this case, like we have that, so the base is equal to ABC. We have that it divides, or like the mod of this would be, the mod of string 2's length and the base's length would be 0. And the same goes for string 1 as well. And so we know that we can divide evenly across both string 1 and string 2 with the given base. So in the next step, what we'll do is we'll try to get the t element in this, essentially, or the t variable. So we'll try to see like the base, like what's the number of times it's divided in string or multiplied in string 1. So we'll get the base. So we get the base divided by, or the string 1 divided by the base. So that'll be 2, because the base goes into string 1 2 times, and for string 2 it'll be 1 time. And then we'll try to replicate this. We'll try to say, okay, so if we multiply the base 2 times, will that be equivalent to string 1? will that be equivalent to string 2? If it's yes, then this is our output. Okay, so let's go ahead and implement this. So we can say that for I in range, the minimum between the length of string 1 and the length of string 2. And we'll go backwards since it'll be fast. It'll just be a bit faster. It'll be all of the minimum length of string 1 and string 2. That'll be like the big O complexity, type complexity. And that's just because it'll be faster if we're able to start from the end, rather than we have to keep going from like A. Okay, are we able to make A? Are we able to make B? A, B? Are we able to make A, B, C? We can just start with A, B, C and go backwards. So we'll start with this. And then the first check we're going to have is, are we able to divide evenly across both string 1 and string 2 with our current like base, our current number base, or index, our current index base, which is just the length of the base, right? So you can say the base is equal to string 1 up to I, and what we'll say is if length of string 1 is mod I is going to be like, essentially what we're saying is 0 is a falsy value, right? So if it's the case that it's either the length of string 1 or the length of string 2, if we are able to get a truthy value out of this, that means that it cannot divide evenly in both string 1 and string 2. So in this case, we'll just pass. So now we can get the actual the number of times we're able to multiply the base in both of the strings. So that'll be n1 and n2, which is equal to string 1, the length of string 1 divided by the base, the length of the base, and same goes for length of string 2. So now we can get the base out of this, and we can verify that if base times n1 is equal to string 1, are we able to replicate it now? And if base times n2 is equal to string 2, that means that that's the base is correct. If we're not able to go through the entire minimum length string and able to create a greatest common divider, like let's say with example 3, then we'll just return an empty character or empty string. Let's see. So the length of the base. So it's just that we have to put this up here first. And yeah, and we also could just have it so that it hits I instead. And that is the solution to this problem. So there is another solution which you can. So this is, as we said, the complexity of this is O of n, which is honestly just O of the minimum of the length of string 1 and string 2. There's no space, like space complexity wise, there's no variables being stored, so we don't need to worry about that. So it's O1. To make this faster, there's actually a solution within the editorial which you can use, which is just essentially recreate, or actually it's in the accepted solutions, and this just like recreates the GCD, which is just including an algorithm. So what you can do here is we can just recreate it now. So we can create a function called GCD, which takes A and B, values A and B. So while A will be assigned to B, and B will be assigned to the mod between A and B, and we will return A. Okay, so then what we can do is we can say that because of how like the mathematical property of how GCD works, you can combine both string 1 and string 2, and if they're not equal, if they're not equal to the reversal where string 2 plus string 1, then that means that this property cannot hold. So there's a commutative property within the GCD of strings. So string 1 plus string 2 is not equal to string 2 plus string 1, then that we just return empty string, and then we can just get the base now essentially. So we can take the GCD of the length of string 1 and length of string 2, and then we can just return the string 1 up to that base. we'll just call it length since technically in our case that we're calling the base an actual string, which gives us a better result. This is actually O of try again tomorrow. It should be very fast though. I think it'll be if I looked in the editorial, it's actually O of n plus m. Yeah, it's actually O of the string 1 plus string 2 instead of the minimum between string 1 and string 2, which yeah, actually I think the minimum between the so it's the minimum of string 1 or string 2 multiplied by the total length of string 1 and string 2. Yeah, that's the correct term.